Welcome to part 3 of our NumPy solution. So in the last video we have run 1000 simulations of our selection process, and now we have here our NumPy arrays with 1000 princes that we selected. And now we want to further analyze the outcome of our simulations, and we will do this with summary statistics, and we will also create some informative graphs. Alright, so now let's again have a look at our results array here, and we can see that we have a lot of 100s. So many times we selected Prince Charming, and we have a lot of zeros. So in many cases or many simulations we do not select any prince at all. And now let's first of all calculate the minimum of our results array. And the minimum should be obviously here 0, and we can use here the min method on our results array. And we get here 0. And we can also calculate the maximum element of our results array with the method .max. And I would expect here 100, of course. And we can also calculate the mean or the average of all elements in our results array. And we can use here the method .mean. So let's calculate the mean here. And we get 50.3. So this is actually quite intuitive, because if we have a look here, we have a lot of 100s and a lot of zeros, and yeah, the average of 100s and zeros is actually 50. And we can also count the number of appearances of Prince Charming, and we can do this with Boolean indexing. So we filter our results array for all elements which are equal to 100. And then we determine the size here of our new array with only 100s. And we get here 359 occurrences of Prince Charming. So we have 1000 simulations, and in 359 cases we get Prince Charming. And we can also calculate the probability or the frequency of getting Prince Charming by dividing here the count by the number of simulations. So 359 divided by 1000, and we get 0.359. So the probability of getting Prince Charming is 35.9%. And now we can also visualize our results, and we use a histogram, and we pass our results array to PLT_hist. And the amount of bins should be max minus min plus 1, so we have 0 as min and 100 as max, so we have theoretically 101 different results, and for each result we want to have one bin, so 101 bins. Then we determine a label for our x-axis, so quality of selected prints, and we determine also the font size of 15. And we set a label for our y-axis, so frequency, and also here the font size is 15. And we also set a title for our graph, so print selection frequency distribution. And we have 100 applicants, a test group size of 50, and we have 1000 simulations. And the font size of the title should also be 15. And you can see here that we changed here from Matplotlib Inline to Matplotlib Notebook. So with Matplotlib Inline, we are actually producing a static graph within our Jupyter Notebook. And by changing it here to Matplotlib Notebook, we are producing an interactive graph. So let's see how it works, and let's run here both cells. And here we can see that we have here an interactive graph. So here right on the bottom we can see here the x and the y values of the point where our mouse cursor here is. So let's go here to Prince Charming. So we have here the x value of 100 and the y value of 358. And here we have the frequency of selecting no prince at all. So our x value is 0 and the frequency is 491. And we can also move here our graph by using here the pan. So we can move here to the right or to the left, or up and down. And we can also zoom in and zoom out by clicking here to zoom. So let's zoom in here into the right end of our histogram. And now it's getting clearer for our eyes. So we have here the bin of Prince Charming, and the frequency is 358. And here we have the bin for the princess with quality 99. And we have about 89 occurrences. And here we have the bin for the princess with quality 97. So we have apparently 31. And now we can go back here to the initial view. So here in the interactive mode, we can actually customize our graph. So we can move it here to the left, to the right, we can zoom, and we can determine here the size of our graph. So we can make it larger or smaller. And once we are happy with our graph, we should stop the interaction here by clicking Stop Interaction. And by doing so, we are getting actually a static graph. And it's like in the mode Matplotlib inline. And if we use Matplotlib Notebook, so if we use the interactive mode for one graph, we should always in the end stop the interactivity, because we can only use the interactivity for one graph in our notebook. So it wouldn't work if we open 2 or more graphs with the notebook mode. And in my experience and in my opinion, the notebook mode is a bit unstable and it is actually less reliable. So I would never use here the Matplotlib notebook setting as default setting. So I would always use here the inline setting. And only if I want to customize one specific graph, I would switch to the Matplotlib notebook mode. But I would never use as the default setting the notebook mode, because if we have many graphs in our notebook and we just open our notebook and run all cells and all graphs, then with the notebook setting, Matplotlib tries to create many interactive graphs, and this doesn't work, and then we are getting actually severe problems. So by default we should always here use the inline mode. Alright, so now we are finished here with our analysis, and we have seen that with the strategy of forming a test group of 50 princes and selecting the best prince in the test group as the reference prince gives us quite extreme outcomes. So either we select Prince Charming or we select no prince at all. And now in the next lessons and videos we want to change our strategy, and that means that we want to run our code many times. And whenever we want to run or use our code many times, we should automate our code by writing a function. And we will do this in the next video, so I hope to see you there. Bye!